like, share, and subscribe to my YouTube channel. Thank you for your support. Hello guys, welcome back. This is YouTube channel. This is Jonathan Goldfish. Okay, so this video is presented by Jonathan Goldfish Education. Okay, so for this video today, we are going to enter the new content among this YouTube channel. Okay, which is the further mathematics with the subject code of the 9231. But this video aims to focus about the paper one of the 9231, which is the further pure mathematics one. Well, pronouncing this paper is very inconvenient, right? So, therefore, for the convenience, from now on, I'm gonna abbreviate for the pure mathematics one as FP1. Okay? So for you to understand right now, right? So let's take a look at the introductions. So for the FP1 or paper 1 in 9231, okay, for the mathematics GC A levels, okay, it costs 75 marks in total, right? And usually FP1 consists of 7 questions. What about for the criteria? Okay, first, you have to access the past questions as your practices. Okay, better to find the older past papers from 2002, I guess, right? For the good grasp in each of the fundamentals, which is conceptions. As well as you have to master the core knowledge from the basic pure mathematics 1 and 3, 9709. And for the third point, alright, is just a paraphrasing from the second point. So for the FP1 syllabus, it consists of 7 chapters. Chapter 1, roots of polynomial equations, rational functions and graphs, summation of series, matrix 1, polar coordinates, vectors, and finally, proof by inductions. But for this video today, we are only focusing the roots of polynomial equations, okay, as this entire video. And I will not enter the chapter 2, rational functions, in the next video except because the next chapter involves differentiations to be discussed on the next video, which is the chapter 7, differentiation. Okay, under the further pure, under the basic maths, pure mathematics 1. Okay, so yeah, let's get started without the nonsense. Chapter 1, roots of polynomial equations. Okay, for this video today, we are going to enter the first chapter, which is the roots of polynomial equations, okay, among the FP1. So let's enter the first subtopic, polynomials, Px. So for the polynomial, okay, it must have a standard form of an with the x to the power of n, where n is the highest degree of this polynomial equation. Let me give it an example. Let's say I have a quadratic equation. What is its highest degree? It's 2, right? Why it's 2? Because of ax squared plus bx plus c. So this is the second degree polynomial equation, but in fact, it is a quadratic equation. Okay? So when we can't name the type of the polynomial equation, we can call it as the n degree of the polynomial equation. Okay? Or polynomial functions, where each of these are the coefficients beside its degree. Okay? So let's say I put n as 4, which means that this polynomial is a 4th degree of the polynomial function. Why? Because of it has a term which consists the highest term or the leading term among the polynomial equations. Okay? So hopefully you take note about this. And for the polynomials, n must be in positive integer. Okay, starting from, let's say, the n, I give you the example as 5. 5, 4, 3, 2, 1. Right? So for the leading term, its coefficient cannot be 0. If its coefficient of the leading term is 0, we can't define its polynomial equations. Okay? or it loses the characteristic already, right? So yeah, this is the end of the subtopic. Let's move on to the second subtopic, which is the basic operations of the polynomials. Alright, well, in fact, these subtopics come from the basic pure mathematics 3, 9709. Stay tuned for my further updates of this video. Of this YouTube channel. So for the basic operation of the polynomials, okay, let the px and qx are both polynomial functions but different at all. Okay, so for the px plus qx or addition, it is just add the sort and add the like terms. Okay, as well as the subtractions, subtract the like terms, sort the terms and subtract. So what about the multiplication? Okay, it is like an expansion. Okay, so multiplication is literally expansion of all of it. And what is the highest power of this leading term of this multiplication? It is just the leading degree. The leading term has a degree. Each leading term has a degree. Okay, the highest power of this multiplication is just this degree plus this degree, or the highest power is the sum of the power of the px and qx. Okay, and for the division, okay, px over qx, its highest power is the degree of px minus the degree of the qx. But usually for the division, it must be a improper fractions. What is improper fractions? It's denominator higher than numerator. Okay, same as it. If you want to define the division as, the quotient function as the proper fractions, the degree of denominator must higher than the numerator. Okay. So let's move on to the next subtopic, which is about the long division. So in case the rational function you got is an improper fractions, or the degree of numerator is greater than the denominator, you must carry out long division in order to obtain a proper fraction term. Okay, so this is how does long division work. And this chapter is actually, this subtopic is actually coming from the pure maths tree. So just use the division symbol from your primary school. Okay, so in primary school, you will learn about division of the numbers. Let's say 18 divided by 8. Okay, and then you put the numbers inside here until you get the remainder, or the remainder is 0. Just close it by two lines. But for this, it is the expression, the polynomials divided by another polynomials with the terms of x. So this one, we will cover this in chapter 2 because this subtopic is very crucial for chapter 2. Okay, for converting from improper fractions to proper fractions. So basically, p over x, if you carry out the long division like this, in the primary school way, just that both sides have x or have the term x until you get this as a quotient and this is as the remainder. Okay? So this is the general formula for the long divisions. After it is carried out, px divided by dx is equal to the quotient plus remainder divided by divisor. So where divisor is the denominator, which carries its specific degree. Okay? So that's fair enough. Okay, let's move on to the next subtopic. I don't think we are going to cover about this because this is the last video we explained already. So this is basically NCR, what we learned from the Pure Mathematics 1, Chapter 6 series, binomial expansion or binomial series. So for this, I'm not going to cover you too much. Okay, so we have ended it's actually the prerequisite topics of the Pure Mathematics 1 and 3 both. Okay, so yeah, let's move on to the actual topic of this chapter. Okay, finally, we are entering the actual topic of this chapter. So here is it. Roots and coefficients of the polynomial equations. Okay, in your syllabus or in your AS syllabus, you will only learn at least quadratic equations, but at most quartic equation. What is quartic equation? It means the fourth degree. Okay, but it is not fixed. Okay, the most crucial part is you have to practice more to grasp about this topic entirely. So let's discuss about the quadratic equations. So what is the general formula of the quadratic equations? Okay, each polynomial equation is equal to 0, which means that you are going to find the roots, right? But as its degree gets higher and higher, and it's hard for you to find the roots because we can't know what is the general formula, but quadratic does. Because of you have the quadratic equation to solve for the roots, which is the x equals to negative b plus or minus b squared minus 4ac divided by 2a. Okay, this is the derivation of the formula from completing the square of the general formula. But for the third degree and the fourth degree, its formula is way too complicated or bewildering, right? So for this chapter, we are not going to use about what formula, but we can use about these two facts: sum of roots, product of roots. Okay? So let's assume alpha and beta. So usually you will see in your external examinations, you will see the alpha, beta, gamma, and even delta are the roots of the polynomial equations. So it depends on the questions, all right? So in your secondary school, what is sum of roots? We can abbreviate it as SOR, POR. Okay, S refers to sum. Sum means plus. Product, P means product. Product means what? Multiplication, right? So the sum of the single root, let's say alpha, for the quadratic equation is alpha plus beta, or it is equal, or this sum of root is equal to negative b over a. Meanwhile, for the product of roots, which is the alpha times beta, okay, or the sum of the product of the two roots, right, which is alpha times beta, and it is also equal to c over a. Okay, and where does this come from? It comes from the division of the a, or letting the coefficient of the highest, the leading term, become 1, right? So same as this cubic equation. Okay, these are the general sum of roots, product of roots. You have to remember about it. So the sum of the single root is negative b over a, negative. Sum of the product of the any two roots is alpha beta, alpha gamma, beta gamma. Because cubic equations, fundamentally, it has 3 roots, right? So you have to consider about the any kinds of possibilities. It has 3 possibilities, right? And for the third one, it is the sum of the product of the 3 roots, which is alpha times beta times gamma. So this is literally negative b over a for the first, second c over a, and negative d over a for the third one. Okay. So these are the general formulas that you have to memorize. Okay, please do it so. Because this formula listed over here, okay, do not exist in the MF19. And you have to memorize by yourself. If you don't memorize and you expand it, it takes you a lot of time. Okay? Huh. So for the quadratic equation, it has the leading term of the x power 4. So which means that this polynomial equation is a fourth degree of the polynomial equations. So these are the general. The sum of the alpha is alpha plus beta plus gamma plus delta is equal to negative BOA. Okay? So to get this, you must divide A for all terms. Okay? So for the sum of the alpha beta or sum of any two roots, which is alpha beta plus alpha gamma plus alpha delta and so on, to get C over A, which is the coefficient of the x squared. And for the alpha beta gamma, or the sum of the any three roots, which is these summations, you get negative D over A, and the product of the all fourth root of out of four roots, you get E over A. So these are the general formulas. Negative goes first, positive, negative, positive, negative. And for the quadratic, negative, positive, negative, and positive. Memorize in this way. Okay? So these formulas are actually derived from the expansion to get their respective degree of the equations, just that they have to sort all of the coefficients for each to get this kind of the derivation results or the outcomes. So no worries, question doesn't require you to prove about these formulas, but you have to you have to know how to use this formula well. Okay? Huh. So I think we have ended the discussion about this subtopic. Okay? So now let's move on to the next subtopic, shall we? Okay, sorry guys. The recurrent notation is still under the same topic of the roots and coefficient of the polynomial equations. So now it's under the same subtopic. Okay, just that this is the next segment. Okay, recurrence notation. So what is recurrence? Means repeat or to get the general formula. Okay, or you can see about the first point, it is the general algebraic expressions. Okay, or it is the deduction, right? So for the general summation in this AS syllabus is represented as Sn is equal to the sum of the alpha power, the degree of the roots. Okay, yeah. So let's say you got the third degree of the polynomial equations. What is the Sn? It's just Sn is equal to alpha power n, beta power n, gamma power n, right? All you can do is so like when multiply the polynomial equation by the xn, the recurrence formula from the polynomial equation can be modified from this, okay, as an example, fourth degree into this. So generally, for defining the general summation of the degree of the each roots, right? The polynomial equation can be expressed from the x power 4 into Sn plus 4 if the Sn, if there is a Sn beside the E, right? Huh. So this I need you to read through by yourself, okay? And I'm going to explain it briefly only, right? Huh. So it is literally the multiplication of the transformation of the recurrence formula. That's why this segment is so-called recurrence notation. Okay? So hence from the um from the derivation above, we can deduce that S1 is equal to the sum of the alpha or the sum of the single roots. S2 is equal to the sum of the alpha squared or the sum of the each roots with the second power. Okay, and for the third, it is the sum of the single root with the third power. And what about the sum of the negative one? So negative one is actually the sum of the reciprocal of the roots, reciprocal of the single roots. Okay, so it's actually the sum of the any product of any two roots divided by the sum of the product of any three roots. Of course, all possibilities must be added up. Okay, so this table, this table I have drawn is for the summary of the recurrence notation for the each degree of the polynomial equations. So for the S1 is alpha plus beta, S2 is alpha square plus beta square, which consists of the well-known form, well-known factorization or the well-known expressions. Okay, it is the basic algebraic, basic algebra. Okay, and for the third degree, even the negative 1 degree. Okay, so generally you only have to memorize until the third degree. Okay, why you need to memorize? Because of save your time to deal with the questions, deal with polynomial questions in when it comes to external examinations, right? So for the cubic and the quartic as well. So yeah, this is the end of the discussion of this segment's recurrence notation. It is just a deduction of the general algebraic expression, right? So that's all about it. Let's proceed to the last subtopic among this chapter. Okay, it comes to the last subtopic of this chapter, relationship and transformation method. So in your pure mathematics 1, chapter 2, okay, you will learn about the transformation of functions. But for this, you are going to learn the transformation of the roots of polynomial equations. Okay, so these are the procedures. First, you have to assume each of the roots are the roots of the old polynomial equation. Okay, this is in order for you to modify from old polynomials, OPE, to new PE. Okay, and the second point says that this aims to modify the roots to get a new polynomial, new PE, by using the recurrence notation, as I have summarized it above. Not it, it's them, right? So these are the actual steps. So first, identify the coefficient of the old polynomial equations. Okay, and by right, the question given is the polynomial equations must equal to 0. Right? And then look at the context of the questions, especially for the transformated roots. Alright? So you have to say that all roots have the same transformations. So these are the examples. Like all roots are multiplied by 2, or all roots are reciprocal. Right? All roots become a reciprocal. So you have to let the new root is equal to y or equal to x, right? And then transform, okay? Because in the end, this alpha will be your x to be substituted inside the old polynomial equation. So this is just the inverse f function of y, right? I know that explaining about these steps are insufficient for you to understand, but we can use exercise for the further um, explanations, as well as the descriptions for your clear understandings. So I will scrutinize each of the steps, right? So the fourth step is substitute the alpha, okay, x equals to alpha or x equals to f inverse of the y into the old polynomial equations, okay, by letting the x equals to alpha, as I mentioned over here. And what's the last step? It is expand and simplify the equation of px into the new polynomial equation. Alright, as the notation shown over here. Right? So these are the steps to obtain the new PE by using the transformation method of the roots from the old PE. Okay, yeah, we have ended the discussion of the chapter 1 roots of polynomial equations lecture. So let's proceed to the exercises, shall we? Okay, time for the exercises discussions for chapter 1. So as the same pattern from the last few videos, okay, the first few questions are from your course book and the last few questions are from your past questions. So out of 25 questions for these exercises, I'm going to discuss only 9 questions, okay, to save time for this video, right? So let's start from question 1, okay? It is from the course book. All right. Each of the following quadratic means what? It has a second degree, right? Second degree. Has the roots of the alpha, beta. Find the values of the alpha plus beta and the alpha beta for each, right? So for the part A, how to get, so you can spot that alpha plus beta is the sum of root, so alpha beta, whole. Sum of roots, product of roots. So you must memorize the general formulas for each, right? So alpha plus beta is equal to -5. That's all. 9. Alpha beta is equal to 9. That's all. Okay? And check about the coefficient of the x squared or the leading term of this polynomial equation is 1. Okay? Before to determine the sum of roots and the product of roots. Okay? And if you obtain the two equations, okay, it is easy for you to find the each of the roots, right? Without using the quadratic formula. But this is not the necessary case. Not necessary case because the question won't ask you to find all of the roots. Okay? Because that's insane. Right, for B, x squared minus 4x plus 8. So usually when you deal with the quadratic equation and the question asks you to find the sum of roots and product of roots, check if the coefficient of the x is negative, and it makes this method makes your job easier, right? So what is alpha plus beta? It's just 4. Okay, because there's a negative beside it. So what about alpha beta is equal to 8 enough? Okay. So this question is quite straightforward, right? Okay. C. Okay. For C, what you can see over here, how does this part become different from the A and B? The coefficient of the x squared is now 2. So we have to get rid about it. How to get rid about it? Divided by 2, right? So to get rid about the 2, we must let the coefficient of the x squared is become 1 divided by 2 for each term. Okay? So you will get x squared plus 3 over 2x minus 7 over 2x. 7 over 2 is equal to 0. Now you are able to determine the alpha plus beta and the alpha beta. What is alpha plus beta? Negative 3 over 2, that's all. Alpha beta, negative 7 over 2, that's all. Okay? This is how you determine the sum of roots and the product of roots of the quadratic from any quadratic equations. Okay? Well, this is literally the prerequisite topics from your secondary school. Right, now let's proceed to the next question. Okay, let's move on to the next question, which is the question 4. Okay, this question is also under the course book. The roots of each of the following cubic equations are alpha, beta, and gamma. Okay, cubic means this equation raises to the highest power of highest degree of 3. So in each case, find the values of the S2 and S negative 1. Okay, recall about what is the S2? Alpha square plus beta square plus um, gamma square. Okay, what about the S negative 1? It is the reciprocal, the sum of reciprocal of the root, each root. So this is the best recall. Or you can expand it as the sum of any product of the product of any two roots, which is alpha beta, alpha gamma, beta gamma. Okay. Yeah, I think that's it. Divided by alpha, beta, gamma. Okay? Huh. Right. So for the part A, x cubed minus 2x plus 5 is equal to 0. So for the coefficient of the x squared is negative 2. So you should aware that the sum of the roots alpha plus beta plus gamma is equal to negative is equal to 2. It's safe because of the coefficient of the highest degree is 1. So the what about the alpha beta, alpha gamma, and beta gamma? So since there's no term of the x, therefore alpha beta, the sum of the product of any two roots is 0. Okay? So this is the fact you need to remember. So when it comes to there's no term, so which means that the other of sum of it must become 0. Okay? Take a look back at this equation. There's no term of the x, which means that the sum of the oh sorry. Yeah, I was right. So because there's no term of the x, which means that the sum of the product of any two roots is 0. And what about the product of the all three roots? Is just negative 5. Why negative? It is the general recurrence notation that you have to memorize. Okay? And hence, find the S2 and the S negative 1 for each of the equations right now. Okay, S2. S2 is what? Alpha, alpha squared plus beta squared plus gamma squared. But we can't substitute inside directly. Instead, you can use this these informations, okay, and modify these equations into the term seen for this any of these substitute inside. So alpha square plus beta square plus gamma square, you must simplify into the expression of the alpha plus beta plus gamma square minus the twice of the sum of the product of any two roots, which is alpha beta, alpha gamma, and beta gamma. Okay? So since you have figured out and derived out the formula of the S2 and the S negative 1. And now it makes your job easier. It's just to carry out substitution. So alpha plus beta plus gamma 2 square. So you can write it like this, 2 square minus the 2 alpha beta plus alpha gamma plus beta gamma is just 0. So therefore the S2 for this, for the part A, is 4. Okay? And what about the S negative 1? How many roots are there? So since this is a cubic equations, we have 3 roots. Therefore, S negative 1 is equal to the sum of the reciprocal of the one single root. And depends on how many roots it has, the equation has. And then you simplify into its general form. Okay, easier for you to carry out substitution. So what is the alpha, beta, alpha, gamma, and the beta, gamma? 0. Alpha, beta, gamma, negative 5. So therefore, S negative 1 for the part A is 0. That's all about it. Okay? No need to think it no need to think it as the complicated ones, right? So do the same thing for the part B and C. Okay? So for the part B, the coefficient of the leading term x cubed is 3 divided by 3 for all terms. You will get x cubed plus 4 over 3 x minus 1 over 3 and equal to 0. Right? So what is the value of the alpha, beta plus gamma? Negative 4 over 3. What is the alpha, gamma, alpha, beta, alpha, gamma, and the beta, gamma? 0. Sorry, the alpha plus beta plus gamma is 0 because of there's a absence of the x squared inside the polynomial equation for part B. What about the alpha, beta, alpha, gamma, and the beta, gamma? Positive 4 over 3. Okay, so this is the trickiest part that you might make the careless mistake, right? And what about the value of the alpha, beta, gamma? 1 over 3, positive, right? Why? Because of the general recurrence notation formula. Please memorize so. Okay, S2. S2 is what? 0 square minus the twice of the 4 over 3. Therefore, you will get negative 8 over 3. This is your S2. And what about S negative 1? It is 4 over 3 divided by 1 over 3. Okay, you get 4. Because of 1 over 3 divided by 1 over 3, both have been cancelled out. So this is the answer for the S negative 1 for part B. C. Yeah, C is very concrete because it has the each term of the polynomial degrees from 3 to 1 and even 0. 0 or it is just a constant, right? X cubed plus 3x squared plus 5x minus 7. Check whether the coefficient of the leading term is 1. Yes. Okay. And next, list out all the informations from the polynomial equations above mentioned. Okay. Alpha plus beta plus gamma is negative 3. Alpha, beta, alpha, gamma, and beta, gamma is 5. And finally, alpha, beta, gamma is 7. Yeah, like this. So what you can see over here for the part C, okay, it is quite it is quite convenient for you to find the S2 and the S negative 1 or answer any different kinds of the external questions. So for the S2, it is negative 3 square. Okay, make sure to be bracket, right? Because of your workings must be implied in front of the examiners. Negative 2, what is the sum of the product of any two roots? It's 5. Right? So negative 3 and s squared is 9. 9 minus 10, negative 1. Okay, what about the s negative 1? It is 5 divided by 7. Yeah, it's just literally 5 over 7. That's all. So usually for the sums, for the sum of the roots in the form of the fractions, leave it so. Okay, usually the answer must be in exact form or fraction form and even integer. Right? Huh. So yeah, that's the end of these questions. Let's move on to the next question to be discussed. Okay, this question, although from the course book, but in fact, this is the this is what the external examination asks you in this kind of pattern or this kind of form. Okay, given a quartic equation as x power 4 with the leading term of the x power 4 plus x plus 2 is equal to 0 which has roots of the alpha, beta, gamma, and delta. State the values of the S1 and the S negative 1. Hence, find the value of the S2. So what is S1? S1 is the alpha, beta, gamma, and delta. Right? With each roots has the degree of 1. So this is easier for you to find. So what is it? It's actually 0. Why? Because of the coefficient of the x cube is 0 for this equation. Okay, what about s negative 1? S negative 1 is the 1 over alpha plus 1 over beta plus 1 over gamma and plus 1 over delta. Okay, so it is just basically the fraction of the sum of the product of the any three roots or possibilities divided by the product of the all four roots. Yeah. Alpha, alpha, beta, gamma, alpha, beta, delta, alpha, gamma, delta, beta, gamma, delta. I think that's I think that's all. Okay? Divided by the product of it is alpha, beta, gamma, and delta. So what is the value of the sum of the product of any three roots? Okay? So see, there is a term x with the coefficient of 1. Okay? Remember that it is the negative, positive, negative, positive for the quartic equation. So therefore, the value above here or the numerator is 1. Negative 1, sorry. And what about the values of the alpha, beta, gamma, and delta? It's 2. So therefore, the s of the negative 1 is negative 1 over 2. That's all. Okay? Hence, find the values of the S2. S2 is alpha square plus beta square plus gamma square plus delta square. So it can be expressed into the bracket square of the sum of the single root with the first degree, with each root is has the power of first degree, minus the twice of the product of the sum minus the twice of the sum of the product of any two roots with the sum of all possibilities or the all possible outcomes. So which has a alpha beta, alpha gamma, alpha delta, beta gamma, beta delta, as well as the gamma delta. Okay? So what is this value? 0. And what is the value of alpha beta plus alpha gamma and so on? It is 0 as well. Why? Okay, because this thing is the almost closely related to the coefficient of the x squared. Okay, where this is the x power 3, x power 2, x, and this is the 0 because of the constant. Okay. Therefore, this thing is 0 as well. Informed from this is the information from the equation above. And therefore, S2 is 0. That's all. Right? So this is how you deal with the the real form of the external exam questions. Right? Okay, let's move on to the next question, shall we? Alright, let's move on to the next question, which is the question 10. Okay, this question is under the coursebook, and this is the last questions before we proceed to the challenge segment questions. Alright, so for the quadratic equation below, it is given that there's a quadratic equation of the 2x squared minus 4x plus 7 is equal to 0, has roots of the alpha and beta. So for A, find the quadratic equation with roots of alpha square and beta square. So what you can see over here, this question is entirely related to the transformations of the roots. Okay, to modify from the old PE to the new PE, right? So for the for A, each root has been squared. All right. So you can say let this is the procedures. Okay, please watch this carefully. First, let the y equals to the transformated roots. I put alpha squared, and then transform into alpha is equal to y 1 over 2, y power 1 over 2, or you can put it as the square root of y. Okay, as long it's equivalent, right? And then substitute the alpha inside the original equations or the OPE, okay, as this equation has the roots of the alpha, or alpha is the one of the root of this equation. Alright, so x equals to alpha. Just replace the x as the y power 1 over 2. Okay? So you put it as 2y 1 over 2 times 2 minus 4y to the power of 1 over 2 plus 7, copy as usual. Okay, so for this power you may cancel it out to get 2y minus 4y to the power of 1 over 2 plus 7. Okay, so but the question asks you to find the quadratic equation. So which means that for a polynomial equation, okay, the degree shouldn't be the fraction, must be in integer and also positive. So how to do it so? Okay, please look at it carefully. So what you can see over here, there's a negative 4y. There's only a y with the power of the fraction, which is the negative 4y 1 over 2. Okay, group into another side. So move it to the right hand side. you will get 4y to the power of 1 over 2 is equal to 2y plus 7. So now this makes your job easier. Okay, what should you do is square at the both sides to get rid away the 1 over the power of 1 over 2 inside the y. Alright, so just take the square at both sides. From the left, distribute the powers for each multiplication, each product. So 4 square is 16, and y to the power of 1 over 2, you square it up, you will get y because of the power of the 1 over 2 and the 2 has been cancelled out. And for the right hand side, you have to expand. You can use the binomial expansion. But since this is the quadratic equation, okay, this should be easier for you. So 2y, you will get 4y squared. 2 times 7, 14, times 2 again because of the binomial expansion. So 28, y plus 49. Okay? So now it's time for you to sort it out. You have 4y squared, okay, plus 12y, and also 49. Yes, 49. So this is the answer for the new PE for the part A. Okay, this is the new PE with the roots of the alpha square and beta square. Okay, Well, let's take a look at the B. So I have to diminish it down to allow me to do the B. Okay, leave some space. So for part B, find a quadratic equation with the roots of the 2 alpha minus 3 and 2 beta minus 3. So this transformation is literally the original root times 2 and then minus 3. So we can see that the sequence is important now, right? So what should you do is let y equals to 2 alpha minus 3. Okay? And then transform it into alpha is equal to y plus 3 divided by 2. Okay? And let x is equal to y plus 3 divided by 2. Substitute inside the OPE. You will get this. Two times y plus 3 divided by 2 square minus 4 y plus 3 divided by 2 plus 7. Okay? So make sure you are not going to make a careless mistake. You have to square y plus 3 entirely as well as the denominator of 2. So you will get 2, the bracket of, what is the square root of the 2, which is 4. And what about the expansion above, which is y squared plus 6y plus 9. And this can be cancelled out. You will get negative 2y, negative 6 plus 7. Okay, meanwhile, this you can cancel it out as well. You will get distribute for each additions, which is the half y squared, 3y, 9 over 2, plus 9 over 2, minus 2y, minus 6, plus 7 is equal to 0. Okay, grouping into the correct sort and simplified it. So you have 1 over 2y squared plus y. Okay, for the constant, you will get 11 over 2. But if you leave your answer of the new PE, okay, this may threat your marks. Okay, so to reduce the risks, you have to let all of the coefficients and the constant become an integer. Alright, so multiply 2 for all sides. You will get y squared plus 2y plus 11 as your final answer for the new PE. Okay. So there you go. Yeah, we have ended the discussion for these questions. So now let's proceed to the challenge segment. So now it's time for us to discuss the challenge segments. So this is the question 12, but it's under the course book questions. Alright. A quartic equation 2x power 4 minus x cubed minus 6 is equal to 0 has roots of the alpha, beta, gamma, and delta. Show that the quartic equation of the roots alpha cube, beta cube, gamma cube, and delta cube is 8y power 4 minus y cube minus 18y squared minus 108y minus 216 is equal to 0, and hence find the values of the S6 and the S negative 3. Okay, so this is how it works. So given here is the OPE as I written over here. Okay, it has the roots of the alpha, beta, gamma, and delta, right? So what should you do is to let the transformator root is equal to y. Y equals to alpha cube. And then therefore, the alpha is equal to y to the power of 1 over 3. Okay? Now, x is equal to alpha. Substitute inside the OPE, you will get like this. 2y to the power of 1 over 3, and then to the power of 4, minus y 1 over 3, and then cube, and therefore minus 6. So simplify it first. You will get 2y to the power of 4 over 3 minus y minus 6 is equal to 0. Okay. And yeah, binomial expansion is still crucial in this topic. Alright? So move the normal terms to the other sides. Just leave a term of the y to the power of 4 over 3. Okay? And what's next? Cube at both sides. For the left hand side, okay, 2 cube is 8. So 8y to the power of 4. For the right hand side, carry out binomial expansions. So using the Pascal triangle, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Okay? So there are four terms after we expand the cube. The cube of the y plus 6. Alright? So it's y cube plus 6 times 3, it's 18. 18y squared. 36 times 3, you will get 108 y, and finally 216 plus. So now we can see the obvious answer already. So what should you do? Just move this entire to the left hand side. So this leads to your answer. Okay? 8y power 4 minus y cubed minus 18y squared minus 108y and minus 216 is equal to 0. So until here, you have successfully to show the new PE of the roots with the roots of the cube. So therefore, shown. Okay? So until here, you have successfully shown that the new PE, okay, after the each root has been cubed. Right? So hence, find the values of the S6 and S minus 3. Okay. So remember what is the Sn for this syllabus, which is the A power n plus B power n plus gamma power n. Alpha power n plus beta power n plus gamma power n plus delta power n. Okay? Ha. So it's basically the sum of the roots with the power root of n, generally, right? Ha. So how to get S6? S6 is A. So you can see that this equation has the roots of alpha cube, beta cube, gamma cube, and delta cube, right? So why not you treat, wait, let me finish writing first. Why not you treat the A cube as only A? Okay, same for the others one, like this. And then change the form into the another expression. Okay, treat it like the square. The sum of the each squares can be simplified into this form, which is a power 3 plus b power 3, gamma power 3, alpha power 3 plus beta power 3 plus gamma power 3 and the delta power 3 square minus the 2, the sum of the product of the any two of the cube of the roots, which is the alpha cube, beta cube, alpha cube, gamma cube, alpha cube, delta cube, and so on. Like this. So using the new equation that you have shown, alright? So what is the sum of it? It is 1. No, it's not 1. Okay? Because of the leading term y power 4, okay, you must simplify away the 8. So divided by 8 for all, okay, which you will get 1 over 8. Why? Because of this is a negative, but the general sum of this, you will get a negative of the negative of this divided by 8. But since negative negative, you become positive, so therefore it's 1 over 8. Right? Minus 2, and what is this sum? Sum of the product of any two roots for each, and sum it all, okay, which depends on here. Alright, so this for this we take positive, negative 18 over 8. So just press your calculators to get your answers. So your final answer should be 289 divided by 64 as your final answer. Okay? And what about for the s negative 3? So for the s negative 3, it resembles like a reciprocal of the single root. Okay? And then just follow the simplifications from the recurrence notation above. You will get. So for the denominator, it is show you alpha cube, beta cube, gamma cube, and delta cube, right? But what about above? Okay, so for the alpha cube, what for its numerator, what is missing? This, and this, right? So we have four additions. I mean the four terms to be summed, okay, with the product of the three roots. Just that we treat the beta cube as a single root for the new PE, right? So you have alpha cube, beta cube, gamma cube, and so on. So I'm not going to pronounce it too long, okay, because this annoys me as well as the audience or each of you, right? Sorry about that. Yeah, there's one more. Okay, there is. And then for this s negative 3, we just have to carry out the deduction only. So what is the values of these summations? The summations of the product of any three roots, and then sum it all. Okay, it depends on the coefficient of the y, which is the negative, positive, negative. So 108 divided by 8. Okay, 108 divided by 8 as the numerator. What about the denominator? Which depends on the constant. Okay, negative, positive, negative, positive. So negative 216 divided by 8. So what you can see over here, 8 and 8 can be cancelled out. And I know this is incalculatable in the mental abacus calculation, sorry. So you will get half as your final answer. Okay, that's all about this question. And this is how the way you deal with the questions of the summation of the roots over here. Okay? But this second part questions is dependent on the last questions or the performance of your previous part. Okay? If you did any mistakes from the previous one, which means that the behind one will be affected. Right? So yeah, we have ended the discussion for the coursework questions. Now let's proceed to the past year questions. Okay, finally we are moving on to the past year questions for this chapter. Okay, so this is question 15 from 9231 May-June 2012. Question 8 from paper 1-3. Okay, so given that there's a cubic equation of the of this particular equation, okay, that has the roots of alpha, beta, gamma. Okay, let's write it out the information first. X cubed minus x squared minus 3x minus 10 is equal to 0 with the roots of alpha, beta, gamma. Okay? So now let's write out the information first. Okay, for you to easier to solve these two questions, these two parts of among this question. What is the sum of the single roots or the sum of the alpha plus beta plus gamma is equal to the coefficient. I mean, it depends on the coefficient of the x squared for the cubic equation, which is 1 only. Because it takes negative coefficient of the x squared, right? And coincidentally, the coefficient of the leading term is 1. That's great because this is very convenient. I mean, our work is convenient now. Next, what is the sum of the product of any two roots for all, which is the alpha beta plus alpha gamma plus beta gamma, is equal to take this coefficient, the positive coefficient of the x, which is negative 3. And what about alpha, beta, gamma? Product of all three roots, it's negative 10. No, sorry, it's positive 10, okay? It just takes the negative constant, which is you get positive 10. Okay? So now we have the information already. Let's solve for first part. Let u is equal to negative alpha plus beta plus gamma. Show that u plus 2a is equal to 1. Okay, let's solve for the part first. The part that I have bracketed over here. So now, use the information for the first that I highlighted right now. State out or imply the u is equal to negative alpha plus beta plus gamma. Right. So, what's the difference between the first and the second? One is the positive alpha and another is negative alpha. But we can't just substitute this directly. Instead, we can do it this way. Let's modify the alpha first, okay, before the substitution. So add 2 alpha for the both sides to make, to modify the negative alpha into positive alpha first. So we have plus 2 alpha, u plus 2 alpha is equal to negative alpha plus beta plus gamma as well as 2 alpha. Okay, sort and simplified, you will you will get positive alpha plus beta plus gamma is equal to u plus 2 alpha. And now, this is it. Just substitute inside that I've used the magenta color to highlight it. So, therefore, u plus 2 alpha is equal to 1. Therefore, shown. So, this is the way how you prove that the characteristic of equation given. Done for the first segment, now for the second one. Hence, find the cubic equation, the new cubic equation or the new PE, which has the roots of the each negative of the roots sum with the other positive roots, other 2 positive roots. Okay, and I've give you a hint. Please add it by yourself in the notes. Okay, because I think that I didn't give you hints. Apologize about that. Well, how to get this? But we can't, before carry out the process that leads to the cubic equation, we can't just to take these results, this context of these roots, to looking for the sum and the sum of the product in 2 roots as well as for the constant. Okay, because it is way too complicated. Since the question has implied that there's a hence word, so which means that you have to take the result from above that you have proved successfully. Okay, let's see for the first one. Alpha, negative alpha plus beta plus gamma. Okay, so let's transform the equation from u plus 2a equals to 1 to u is equal to 1 minus 2 alpha. Sorry. Yeah, that's correct. And then, so since this is u, right? So this is equal to u, and what is u? 1 minus 2 alpha, right? Okay, we can modify each roots from this into this, into the single 1 minus 2 alpha. What about for the rest of the 2 roots behind? Okay, so which means that it is the sum of roots, just that except one of the roots is negative inside the sum, inside the summation. So for the second one is alpha minus beta plus gamma, and the negative for the gamma as well. Okay, how to modify it? And this is for the verification of make sure that each of the root has transformed into 1 minus 2 of the older for the old roots for each. Okay, this is literally the deduction. So I want to get rid away the other 2 roots to get the single roots only. In terms of the single root for each only. Alpha, we can change it into 2 alpha minus alpha. And beta, I want to make it positive. So it's beta minus 2 beta. And the positive gamma remains unchanged. Group this together. 1, 2, 3. Negative alpha plus beta plus gamma. Okay. And don't forget the 2 alpha. Like this. You can bracket it away to avoid confusion. Yeah, just like that. So we have u. We have u over here. Oh, sorry. There's no. The gamma has sort to the first one already. There's a negative 2 beta for the outside. Okay? And now we have substituted as u plus 2 alpha negative 2 beta. And you can see that u plus 2 alpha is equal to 1, right? This is 1. So just place it 1. 1 minus 2 beta. And after the two dilutions, we can conclude that for the third roots, its root for in the terms of the single root, which is for the third one lah, it's 1 minus 2 gamma. Okay, this is the result. Just copy the recurrence notation result. You should expect it. Now solve it like the normal way. Okay? No need to expand and simplify it, because this increases the risk of the mistake. Right? So now we can say let y is equal to 1 minus 2 alpha. So therefore, alpha is equal to 1 minus y divided by 2. Alright. And then copy the OPE. You can say x is equal to alpha. We have 1 minus y divided by 2 cube minus 1 minus y divided by 2 square minus 3, 1 minus y divided by 2, and minus 10 is equal to 0. For the first leading term, use the binomial binomial expansion. So it's 1 minus 3y plus 3y square minus 3, it's minus y cube divided by 8. For the second term, it is 1 minus 2y plus y squared divided by 2. For the third one, you will get negative 3 minus 3y divided by 2. Sorry. For the second term, it should be 4 for the denominator. My mistake. And copy the minus 10 as usual. And what you can see over here, there's 8, 4, 2. All are likely the factors of 2. Not likely, it's exactly. So multiply by 8 for all to get rid the denominator for each term. So you got 1 minus 3y square, negative 3y plus 3y square, negative y cube. Okay, since you multiply 8 for the 1 over 4, so which means for the upper term you multiply by 2, what will you get? Negative 2 plus 4y negative 2y squared. And what about this? This you multiply by 4 because 8 over 2 is 4. So it's negative 12 plus 12y. And for the 10, it's negative 80. Now, group and simplify. Sort and simplify. You have negative y cube. What about for the y square? Y square term is 3 minus 2, right? Yeah. So you get a single y squared. What about for the y? Negative 3. Okay, negative 3 plus 4 plus 12. You get positive 13y. And the rest of the constants, it's 1 minus 2 minus 12 minus 18. You get negative 93. And since for the cubic equation, y cubed is the leading term because of the highest degree of 3. But I want to make the coefficient of it to be positive. So, just change the sign for each term. You will get y cubed minus y squared minus 13y plus 93 as the new PE with the roots of the sum of the 3 roots except for 1 root is negative. Okay, so here's the answer. Okay, so here's the shortest and standard as well as the neat way to deal with this kind of questions, which is the new roots of PE. Okay, they won't let you know what kind of the roots they want you to modify. Okay, only to use the algebraic concepts that leads to a single that leads to the looking like a complicated questions into the easy way. So yeah, move on to the second part. So apologize that I didn't give you a sufficient space. Alright, you can create the new page by yourself. Okay, let's go for the second part. State the values of the alpha, beta, gamma. Okay, that's easy. It's just this one as your first part of the answer for the second part. So alpha, beta, gamma is equal to 10. That's all. Hence, find the cubic equations that has the roots of the reciprocal of the product of 2 roots for each of it. Okay. It wants the new cubic equation with the roots of the beta, gamma, alpha, gamma, and the alpha, beta, right? So just modify this into, modify each of the root into the term of the single root only. Alright, so for this, you will get, you see, given that the alpha, beta, gamma is equal to 10, from the hint above, I gave over here, use the info from the OPE as well as the alpha, beta, gamma value that you have stated. So, beta, gamma is equal to 10 over alpha. And you swap it into 1 over beta, gamma is equal to alpha over 10. And this is the best evidence to deduce and simplify each of these roots with the multiple roots into the term of single root. So we may modify it to each of the root divided by 10. Right? So yeah, this makes your job easier now. This question seems difficult, but if you rethink into another way, and the workings is easier than you thought. Alright? So just do it like as a normal steps. Let y is equal to alpha over 10. So therefore, alpha is equal to 10y. Okay. When x is equal to alpha, copy the OPE from the context above. Alright? Yeah, this should be easier because of it's just only multiply. It's just only raised up to the power of each degree only, which is the 10y cubed negative 10y squared negative 3 times 10y minus 10 is equal to 0. Use your calculator to evaluate and simplify the coefficient for each term. You will get 1000 of y cubed, 100y squared, 30y minus 10 is equal to 0. Okay. Well, this is your answer. Okay? Don't carry... So this is my suggestion over here. Try not to carry out an extra and unnecessary step by simplifying, dividing by all of this. I know that each term can be divided by 10, but it is very risky. So don't do that. Alright? So here's my best advice. But if you want to simplify by yourself, it's optional, okay? It's all up to you. But I'm afraid that examiners will deduct your marks if you don't follow my instructions or my advice, okay? So yeah, we have finished the discussion for the question 15 as our first partial discussion among this video. Right, let's move on to the next question. Alright, here is the next questions under the challenging segment, which is the question 17 from 9231, May-June 2005, question 4 from paper 1. Okay, because paper 1 is a further pure mathematics. It doesn't have the separation of the two parts. Right, show that the sum of the cubes, highlight sum of the cubes of the equation below, highlight the equation, is negative 3. Alright, so let's see the first part of this question first. Alright, no rush. If you rush, this might confuse you. So what is the sum of the cubes of the root? It has the definition of the S3 is equal to alpha cube plus beta cube plus gamma cube. Okay? Assume that this equation has the roots of the alpha, beta, and gamma. And given that the sum of the cubes of the roots is equal to negative 3. So this is the result. This is the statement that it wants you to prove. So obtain the information, I mean the sum of the roots from below. Okay? So you don't have to obtain the sum of the roots for each by looking at each coefficients. So for instead, moving the two terms to the other side, where has the degree of 3? This one remain on the left hand side. The rest move to the right hand side. Okay? From the recurrence notation, we can modify the polynomial equation into sum, in terms of sum, which is S3 is equal to negative lambda S1. What about 1? It's S0. Okay? So what is S0? It carries the definition of alpha power 0 plus beta power 0 plus gamma power 0. Or it's just basically the sum of the roots for each with the power of 0. 1 plus 1 plus 1, you will get 3. And what about S1? It is alpha plus beta plus gamma. So do you see any coefficient of the x squared? No. None of the x squared term is seen from the equation. Therefore, S1 is equal to 0 in this method. Okay, substitute the informations that you have found over here. Negative lambda times 0, negative minus 3. Okay, therefore the S3 is equal to negative 3. Therefore, shown. Okay, this is how you obtain the information, substitute inside, and then perform your workings, perform the proof until you get the answer expected from the context of questions. Okay? Second, show also that there is no real value of the lambda, okay? No real value of the lambda for which the sum of the fourth power of the roots is negative. Okay, what is no real value? It means that the lambda is not a real value, right? Next, what's the next information? It is given sum of the fourth power of the roots is negative. It means that S4, when it comes to the S4 is equal to alpha power 4, the sum of the fourth power for each roots, like this. Okay? We can modify this into this one, which is alpha square plus beta square plus gamma square negative twice of the alpha beta square alpha gamma square beta gamma square. So just use the formula that you have memorized over here. Prove it so. We have alpha beta, alpha gamma, beta gamma square, okay, minus the 2 of the alpha square beta, alpha, alpha square beta gamma, alpha beta square gamma, and alpha beta gamma square. Okay? And now you factorize into alpha. We just copy this as usual. Alpha beta gamma, alpha plus beta plus gamma. Okay? And for this, you copy as usual, which is very complicated. Alpha plus beta plus gamma square negative 2 of the alpha beta. Very long. Alpha plus beta plus gamma negative 2 alpha beta alpha gamma and beta gamma. Okay. So what you can spot over here, what is the value of the alpha beta gamma? It's 0. So this is 0 and this is 0 as well. Okay, so what we left over here, and what about the lambda over here? The lambda is the coefficient of the x, right? So according to the equation above alpha beta, alpha gamma, and beta gamma is actually equal to lambda positive. So use this fact from the informations of the equation above, substitute it as negative 2 lambda, and don't forget the square, minus twice of the alpha beta gamma is actually negative 1, but it is multiplied by 0, so it's useless. Okay, these terms, which means that these terms are all gone. All right. Lambda square. Okay. And next, what we have over here, it is 4 lambda square, negative 2 lambda square. So what you can see over here, you got 2 lambda square is is equal to S4. Okay. And what you can see over here, for the lambda, right? It is always positive, right? But it is given that for the S4 is negative. No, 2 lambda square is always positive, and this statement is false. We can't agree the statements mathematically because the 2 lambda square is always positive. Why? Lambda square is always greater than 0. Not greater or equal to 0. But we can't define that the square term is negative. Okay? So you have to write a statements to prove that for the S4 is negative, there is no real solutions for the lambda. Instead, the lambda can be complex numbers. Okay? So you can say that for the sum of the fourth order roots is less than 0. Okay? Lambda isn't a real numbers. Okay? Because of 2 lambda square is always positive. That's all. Therefore, shown. Okay? Don't need to explain it too much. Just say 2 lambda square is positive. It is impossible for the S4 to become negative. Alright? Yeah. So this is how we do the questions of the proof targeting to the roots of polynomial equations by using its fundamentals. Good. So we have ended the discussion for the question 17. Let's move on to the next question. Okay, let's move on to the next question, which is the question 20. It is the partial questions from 9231, October, November 2007, question 4 from paper 1. Okay. The roots of the equation below has the roots of alpha, beta, gamma, as I have written over here. Show that, okay, the question asks you to show that the equation here exists by using the informations of the sum and product of roots. Okay? So let's analyze right now. Okay. See the coefficient of the x squared, which is negative 8. That means, the sum of the roots alpha plus beta plus gamma is equal to 8. And since there is no x term present inside the equation, therefore, the sum of the product of any two roots with all possibilities, alpha beta plus alpha gamma plus beta gamma, is equal to 0 technically. What about the product of roots, which is so-called alpha times beta plus gamma is equal to negative 5? Why? By following the rules of the sum and product of roots, okay? There is a constant of 5, okay? Let's say we take the constant of 5. The product of roots must be in negative. Negative, positive, negative. Okay, now it's time for us to prove this equation out. Okay? Now, restate the second line of the sum of the product of any two roots. And what you can see over here, it wants alpha square exists inside, right? So factorize the alpha square for the first two lines. As I have highlighted over here. Okay? So now you have the factor of the beta plus gamma already. And next, I want to get rid the beta, gamma by referring to the product of roots over here. So alpha, beta, gamma is equal to -5. And to get rid of beta, gamma, which is beta, gamma is equal to -5 alpha. Okay? So this is your equation 1. Meanwhile, this is your equation 2. Substitute the equation 2 by replacing away the beta, gamma. Okay? Into. So now let's substitute the second equation into the first equation, which you will get alpha times beta plus gamma negative phi over alpha is equal to 0. Now rearrange. By right, we will get the result of the equations or the answer stated from the question. Okay, so this is how you use the information of the sum of roots from the particular equations to prove the result out. This is what the examiner wants. Okay, so since we have successfully proved this equation out, therefore shown. Okay, now let's see the second line. I mean the second context. So it is given that the roots are all real. Okay, so for the alpha, beta, and gamma subsets to real numbers. Without reference to a graph, show that the one of the roots is negative and the other two roots are positive. So please write the hint by yourself. Okay, sorry about that. I forgot to write the hint. Okay, but anyway, I hope that you have noted about this. So referring to the first line, as I'm highlighting now, alpha plus beta plus gamma, or the sum of the single roots, is positive. Okay? So which means that maximum only one root is negative. But this is obviously and technically not enough evidence. Okay? We can see another evidence by referring to the third line, which is the alpha times beta plus gamma is equal to -5. So what you can see over here that out of 3 roots, there is a root is negative. However, this is still insufficient evidence to prove that one of the roots is negative. So instead, take the equations that you have proved from the last context, which is the alpha square is equal to phi over beta plus gamma. Okay, so if you swap like this, you will get beta plus gamma is equal to phi over alpha squared. So this is clearly evident that beta plus gamma must be positive. Okay, so we assume that all of the 3 roots are non-zero value. Okay, so now over here, alpha can be positive or negative. So based on the analysis given, obviously the alpha is negative. So therefore, one of the roots is negative. The first word, okay, shown. Alright, and what's next? Beta plus gamma must be positive over here. Okay, because since the phi over alpha squared is always positive due to there's an alpha squared that raises to the power of 2. So which means that alpha squared cannot be 0. Right? To avoid undefined. Well, there's another proof that beta and gamma, both beta and gamma are positive, and therefore the other 2 roots are positive. Okay, you don't need to carry out the calculations, right? just to provide the simple description or the justification. Okay, you don't have to think it complicatedly, right? Therefore, shown for the third one. Okay, this is how you analyze the roots of the equations, observe, and provide the workings that leads to the equation that um, that the question wants you to prove it, as well as some short justifications over here. Clear? So if clear, let's proceed to the next question. Okay, here comes to the last question for our discussion of the exercise today, which is the question 23. It's also the passing questions from 9231, May, June 2009, question 1 from paper 1. Okay, so there's an equation of the fourth degree, right, that has the roots of the alpha, beta, gamma, and delta. By using the substitution of y equals to x cubed, or by any other methods. Okay, you can use whatever approach you want as long you must able to find the new polynomial equations from the transformations given. And hence find the exact value of the sum of the roots with the sixth power. Okay, there we go. So you must okay. Let's set the questions for ourselves that you must find the new polynomial equations with the roots of the alpha cube, beta cube, gamma cube, and the delta cube. So by letting the y equals to x cube, maybe for this, it's transformations of the roots with the third power. We can change it into alpha is equal to y over y to the power of 1 over 3. Okay? And x is equal to alpha. Substitute inside. Substitute these transformations into this equation. Okay, this is the basic procedures that you have to grasp. Okay, simplify the expression carefully. Alright, like this. Y plus 1. So to get rid the 1/3 of the powers, we should take the cube at both sides. So for this, use the binomial expansion 1331 from the Pascal triangles as the coefficient of each term. Right? So you have y cubed plus 3y squared plus 3y plus 1. Okay? Move everything to one side. Let all of them is equal to 0. Okay. So now let's analyze the information of the sum of the roots from the new PE obtained. Okay, now we have the new polynomial equations with the roots of the alpha cube. I mean, each of the roots with the third power. Okay, so we get alpha cube plus beta cube plus gamma cube plus delta cube, or the sum of the single roots is plus 1 because the coefficient of the y cube is -1. And according to the rules, it's positive. And what about alpha beta, alpha gamma, alpha delta, beta gamma, beta delta, gamma delta, or the sum of the product of any two roots for all possibilities? You will get -3. Because according to the rule, the coefficient of the y squared must be must be take the whatever value it has. Okay, so we just need these informations. Oh, sorry, this should be cube, cube for each, because each root has been transformed, right? And now it wants the value of the sum of the roots with a 6 power. Alpha power 6, all and so on. Not so on, it only has 4, right? So think about 6 is the product of 3 times 2. So we need that's why we need the new PE with the roots each has transformed by third with the third power. Think it like this. Separate the products by following the indices rule. Okay? Write this into another form. So in external examinations, you just write the workings until here to show that you have the full grasp in express the sum of the roots with the how many power. All right, so this is beneficial for you. Okay, the next you can just directly write the numerical workings. Okay, to save your time to do other questions. So you will get 1 square minus the twice of the -3. You will get 7 as your final answer as the value of the sum of the roots with the 6 power. Okay? So as you can see, the context of a question seems complicated, but if you keep practicing, it gets easier. Right? So yeah, we have ended the discussion of the questions, and also we have ended the chapter 1 already. So here's the declaration. I declare that chapter 1, roots of polynomial equations, has officially ended. So now let's move on to the summary for chapter 1. Alright, here's the summary of the chapter 1, roots of polynomials, before this video ends. Okay? First, for polynomial equations, it must have a leading term with the highest power to represent its degree. Its degree polynomial equations. Okay? And these are the fundamentals from your pure mathematics. I'm not going to explain too much. So let's focus about the actual topic. Alright? So instead of using the memorizing approach, you must get to familiarize about this sum of roots, and also the rules. Okay? You must take a good grasping about these concepts. Very important, I tell you. Okay? And also the recurrence notation in your syllabus, the general summation, which has a Sn, S6, which is the sum of roots with 6 power. Like our exercises just now. Like the exercises we discussed just now. Okay? And these are the general recurrence formula rules, or this is the deductions for each of the degree of root. So in your syllabus, you will touch at most 4th degree, but at least 2nd degree. Okay? And also you need to get sophisticated to the transformation method that transforms from old PE to the new PE by depending on the transformation of the roots. Okay? So this is the end of the summary and the end of the videos. Alright? So in the next video, we are going to jump back to the pure mathematics 1, and also we are entering the calculus anyway. Right? So yeah, thanks for watching. I will see you in the next video. Goodbye. Thank you for watching this video. Be sure to like and share this video and subscribe to this channel. I will see you in the next video. Goodbye.